This is Mr. Hill with another linear relations tutorial. By the end of this video, students will apply data management techniques to investigate the relationship between two variables, demonstrate an understanding of a constant rate of change, and its connection to linear relations. Students will connect the various representations of a linear relation and solve problems using the representations. For this video, we're going to expand things a little bit, and we're going to express a linear relation as an equation in two variables, using the rate of change and the initial value. We will describe the meaning of the rate of change and the initial value for a linear relation arising from a realistic situation. For example, the cost per topping. And lastly, we will pose problems, identify variables, and formulate hypotheses associated with relationships between two variables. And this is the last kind of segment of our pizza problem, and we will be asking, what is the quickest method to calculate the cost of a 30-topping pizza? Let's explore. So once again, let's read the problem once, and we'll read it a second time and highlight some of the important information. So Michael's first job at Michelli's Pizza is going well so far. His boss was so impressed with the new menu he created that he is thinking of allowing Michael to take orders full-time. Remember that Michelli's charges $14 for a cheese pizza and $2 for each additional topping. For the last step of Michael's training, his boss wants him to develop a quick method to determine the cost of a pizza in the case that a customer needs to know the cost of a pizza with 30 toppings. What is the quickest method for solving this problem? Okay, so let's have another look. So it's Michael's first job, it's going well. His boss was so impressed with the menu he created that he's thinking of allowing Michael to take orders full-time. So it looks like he's getting maybe a little bit of a promotion. That's great. Remember that Michelli's charges $14 for a cheese pizza and $2 for each additional topping. So the last step of Michael's training, his boss wants him to develop a quick method to determine the cost of a pizza. So we need a quick method. In the case that a customer needs to know the cost of a pizza with 30 toppings. So the cost of a pizza with 30 toppings. So what is the quickest method for solving this problem? Now, where do we begin? So there's a couple of things that we've learned from previous problems that we can highlight here. And so, we did learn that that they charge $14 for a cheese pizza, and we called this base cost. And we charge $2 for each additional topping. And we came to explore that this was our rate of change. Now let's see if we can come up with a quick method, or see kind of with a little bit of experimentation, what is the quickest method for determining the cost. So one of the things that we need to know the cost. Let's C represent the cost of a pizza. So what is the cost of a pizza with no topping? So if we have 0 toppings, our cost is equal to, well, it's equal to our base cost, right? Which is $14. Now if we have 1 topping, our cost is equal to 14 plus $2 for 1 topping. We can go ahead and calculate this, but I think we're looking for something that's quick here. And so let's just explore what's happening here. For 2 toppings, our cost is 14 plus 2 plus 2. And for 3 toppings, our cost is 14 plus 2 plus 2 plus 2. Now, can you imagine doing this for 30 toppings? It seemed like it might take us a really long time to add 30 times. So let's see if we can explore something that's a little bit different. Remember that our cost is getting bigger, so we have options here. We were using the method of addition. And so because we're getting bigger, we can use addition, or we can maybe come up with a way to use multiplication in a way that's a little bit quicker. So let's see if we can explore that. So for a 1 topping pizza, 2 is the same as 2 times what number? Yeah, you're right. 2 times 1. So our cost is equal to 14, right? Our base cost isn't changing, so we're not multiplying that by anything, but it's staying the same. So our cost is 14 plus 2 times 1 topping. Now if we have 2 toppings, our cost is equal to 14 plus 2 times what number? Well, we have 2 toppings, so we're going to multiply it by 2. And if we have 3 toppings, our cost is 14 plus 2 times what number? Well, how many toppings do we have? We have 1, 2, 3. So it's 3 toppings. Now, it looks like I'm starting to see a little bit of a pattern here. And so we've gone ahead and we've declared one variable. But if you think back to some of the earlier pizza problems, we came up with 2 variables that we'll see represented the cost. And what does this number represent? Yeah, you're right, it represents the number of toppings. So what's a nice variable that can represent the number of toppings? Well, n is always a great variable for the number of anything. So if we continued this on, we could see that our cost was equal to 14 plus 2 times the number of toppings. Now if I wanted to figure out the cost of a 30 topping pizza, I could simply substitute 30 for n. C is equal to 14 plus 2 times 30. If I work that out on my calculator, so remember we need to do multiplication first for our order of operations. 30 times 2, which is equal to 60. So C is equal to 14 plus 60. And 14 plus 60, so we have 60, so we can add 14, and we end up with 74. So the cost of a 30 topping pizza is $74, and it seems like this method is much quicker than adding 2 30 times. If I think back to some of the other methods I use, it would take a long time to get to 30 if I was using the step method, or it would take a long time for me to create a table with 30 values. So often an equation is the quickest method for determining the cost when we have very large numbers. It was a little bit of work to come up with this equation right here. Let's see if we can use some of the important information that we've learned throughout this chapter to see if we can quickly come up with this equation right here.
Since we're dealing with a linear equation, we can always use the general equation of a straight line to represent a relation. The general equation is y equals mx plus b. And there are a couple key terms that we need to understand when we're using this equation. M stands for our slope, also represents our rate of change. Our b value represents our initial value, which sometimes is called the flat rate or base cost. X represented our independent variable, and Y represented our dependent variable. So one of the things that's really handy is that from our equation we know the rate of change and we know our base cost. Remember, our rate of change was $2 and our base cost was $14. So just by knowing these two values, I can substitute those into my equation. Y equals 2x plus 14. And remember back to our first part of the pizza problem, y represented our cost and the x represented the number of toppings. So either one of these equations work. It all depends on how you declare your variables, but if you declare your cost is being represented by the dependent variable y, then you can do that. And likewise goes for x. If you want to use x to represent the number of toppings, then you can use x. But if you want to use something that is more similar to the word that you are describing, then you can use c for cost and n for the number of toppings. And just like that, we have come up with the same equation to represent the cost of a pizza that depends on the number of toppings ordered. So, we'll explore this in videos to come, but thank you for watching, and keep watching these videos, and we'll learn a little more about linear relations as we progress through this unit. Thank you.